Here's the 3.2 Fakie tutorial. On number one, there's not much to it. We know that if we dissolve this, we get one of these and two of that. You're expected to know that, especially like on a real AP test or in college. And so the molarities are just going to be matching whatever this is and double of whatever this is. If you dissolve 5 of these, you get 5 of those, and 10 of those, it's double, right? So this number matches, and this number is double what we just said, so it's that. If we have silver iodide here, we know that when we dissolve it, we get one of these and one of those, and we're looking for solubility product. That is the official name for KSP. That's what we're looking for then. And we get 1 and 1. These are the same number, and in fact, they both match whatever this is. If we dissolve 5 of these, we get 5 of that and 5 of that. And so the molar solubility is the S value we said. So they're telling us S, not that S, that's solid. They're telling us how much molarity we can create with this. And these two numbers match each other, and they match however many you dissolved of this. So these are both the same number. And then we just multiply them together, and then that is the KSP. Here's my fictional solid. When we dissolve it, we get one of these and two of that, sorry. And then K is, products over reactants to the power of the number in front, except we don't really have a reactant in our K math this time because that's a solid. So we are going to get one of these and two of that, but then everything is the power of the number in front. So we get one of these, the power of 1, and two of these, twice as much of that, but also to the power of the number in front. So this is also squared. This all multiplies up to 4s cubed. Don't forget to square the 2, which is a pretty common mistake, which we've all done. So we put in K is equal to 4s cubed. And at this point, I was kind of just showing something that we could move the decimal here, in which case it becomes times 10 to the power of -8. And that lets me do this. When I divide by 4, I get 2.7 e -8 equals s cubed, which lets me then change this to 27 e -9. And I can cube root this in my head because cube root of 27 is 3. 3 times 3 times 3 is 27. And I know how to take the cube root of e -9 because what we're saying is 10 to the sum power times itself 3 times is 10 to the -9. And we learned that when we're multiplying a common base like 10 with exponents, the exponents actually add up. So what we're looking for is something in the box that plus itself with 3 of them is -9. This exponent plus itself, 3 of them total, will achieve -9. And so what's in the box is -3. So 10 to the -3 is the cube root of 10 to the -9. And that then is the molar solubility. And if you really want, you could call that S. We are looking for the idea of would the silver sulfite precipitate? Well, the way to find that out is to see if Q is greater than or lesser than K. I know you can see the answer there, but we'll see how we can do that. So what we need to do is find Q and compare it to K. Well, what is Q? It's products to the number in front, to the power of the number in front. So what's the reaction? So here's my solid, and we'll get 2 of these and 1 of that, 2 of this and 1 of that, which means we'll get this molarity, brackets is molarity, squared times this molarity to the first. What I need is the molarities. So here's the hole in my information. I need this number and this number. So going back here, we can get them. Now, let's make sure that we know that the sodium and the nitrate are super solubles, and so they won't matter in this because there's no way they're going to be part of a precipitate. So we're going to ignore them and just throw them out, essentially. The Ag plus then will get 1 each out of this, and the sulfite will get 1 each out of that. Because look, there it is. Excuse me, we'll get 2 of these. It's true that we will get 2 if we were dissolving a solid, but we're not dissolving a solid. We are told flat out, this is the molarity of the silver ion. So let's not double that. That is the molarity of the silver ion because it came in already dissolved. We're pouring these ions together in an aqueous solution each. So here's the molarity. And molarity times liters is moles. And then somebody says, well, that's not liters. Right, but we're going to do a tiny mathematical cheat because what we really need is the new molarity. So when we poured 80 milliliters and 60 milliliters together, it became 140 milliliters. So this can be called the millimoles. And then when we divide by the new volume, the milliliters cancels out and we get the new molarity. Remember, brackets means molarity. So here's the new molarity of the silver ion. We can do the same thing with the sulfite ion. Here's the molarity times the sort of liters and divided by the new liters gives me the new molarity because up here is moles and down here is the new liters. So we get moles per liter. If you really wanted, you could turn this into liters and this into liters, but I promise you'll get the same answer. And in fact, what you've done then is divide by 1,000 on the top and on the bottom. So that cancels out before you can even get going, really. So it's really a waste of time. You will get the same number. Why did we do this? So that we could put it, remember, in for here and here. Don't forget to square it. And I'm sure I've done that one. You just forget to square it, even though you wrote it here. And this squared times that is this. How do we compare it to K? Well, it is bigger than K because K is 10 to the negative 3. Sorry, is 10 to the negative 14. And this is 10 to the negative 12. And bigger is less negative. And Q is bigger than K. So what we've done then is, just to make a little bit of a metaphor, if K is here, we've tried to achieve that. And it's just not possible. K represents a point where you can't go past in combining these ions. You simply can't put that much aqueous ion of this and that together. When you hit the value, multiplied and squared and multiplied, of K, nature simply won't go past it. And it will start causing a solid to form, a precipitate. So stuff will precipitate out, that's the verb form. And you can write down that you will achieve Q, but in reality, you just won't. And so if your math said that Q will be bigger than K, it won't really happen. You'll form a solid immediately. And we'll get a precipitate. So the answer is there will be a precipitate. 5 is similar to 4 in that we're going to compare Q to K. So we want Q compared to K. We need to find Q. What is Q? Well, it's products to the power of the number in front multiplied together. So if we put together this lead ion and this iodine ion, what would happen? Now, I know it says a saturated solution, so that's a giant clue that it holds as much as it possibly can. But first, we're going to prove it. We probably shouldn't say saturated. I'm going to have to change that. Well, if we add this much, how much would dissolve? Would all of it dissolve? Let's write out the aqueous solid dissolving equation. Here's the solid. We get 1 of these and 2 of those. And how much do we have? Well, we have 2 grams, sure, but we convert this to moles and we divide it by the liters to get the molarity. This would be the molarity that we would be achieving if it all 2 grams, dissolved. Is that possible? Well, we have to compare Q to K. So if we had this molarity of this, we would then get the same number and double the number. So we get this, that's S to the first and 2S squared, which is why we get 4S cubed down here. So put in the value for S cubed times 4, and we get this. How does that compare to K? K is this, E negative 9. This is E negative 8. This is bigger. So you can put 2 grams of lead 2 iodide in there and stir all day, but you'd be trying to achieve a Q that is bigger than K, so it can't happen. So it would be saturated, it'd be as full as you can get it, and some of the solid would still remain. Now, if we added another liter of distilled water, that would mean we had 3 liters. So let's run it at 3 liters. Let's take the same moles, that's the same number you're trying to dissolve, and put it in 3 liters, which means this is the new molarity. In which case, this is the number we put in for our 4s cubed, which means this is the value for Q. Q is greater than K because this is a 10 to the negative 9. This is a 10 to the negative 8. Bigger is less negative. So Q is bigger than K. So the solution is still saturated. You still can't put all this in, even using 3 liters. And any saturated solution of the same stuff at the same temperature will have the same molarity. Yes, there's more, but per liter, it's the same number.